Hello everyone, welcome to our report video titled Green Transformation of Chili Production Systems in Sleeman, Mitigating GHG Emissions Through Agroecology. This video presents an innovative approach to reducing greenhouse gas emissions from the agricultural sector, focusing specifically on chili cultivation, one of the leading horticultural commodities in Sleeman, Yogyakarta. The agricultural sector contributes approximately 24% of total global greenhouse gas emissions. These emissions primarily result from the use of nitrogen-based fertilizers, water management practices, and soil tillage. Sleeman Regency is designated by the Indonesian Ministry of Agriculture as the national chili producing region. If a food estate is developed in a large area and throughout the year, it will have an impact on increasing GHG emissions. In Sleeman, chili cultivation is carried out intensively and contributes to NOx and SHANE emissions due to the use of synthetic inputs and inefficient water management systems. Chili production in Sleeman involves a series of processes, including land preparation, fertilization, irrigation, and harvesting. However, this production system carries a high risk of greenhouse gas GHG emissions due to the use of chemical inputs, the burning of crop residues, and conventional irrigation practices. Therefore, an environmentally friendly, agroecology-based approach is urgently needed to address these challenges. Then the question is how to mitigate GHG emissions in chili cultivation in Sleeman Regency. Approach 1. Organic mulches such as straw and compost are applied to cover the soil surface. This approach helps lower soil temperature, suppress weeds, and reduce water evaporation by up to 30%. In addition, mulch enhances the decomposition of organic matter, enriching soil carbon and supporting microbial balance. However, a key challenge lies in the availability of materials and the potential introduction of weed seeds if the mulch is not properly composted. The benefit this approach is reduce nitrous oxide emission up to 27%, increase the soil organic carbon and promote sustainable nutrient cycling. Approach to use drip irrigation. Drip irrigation is an efficient solution that delivers water directly to the root zone. This technique conserves up to 60% of water and reduces NO emissions from excessive denitrification. Local studies have shown that drip irrigation can lower NO emissions by up to 35% compared to conventional systems. The main challenges include high initial investment costs and equipment maintenance. Benefit use drip irrigation is reduce nitrous oxide, carbon dioxide, and methane emission by 35 to 45%, increase water and nutrient use efficiency and reduce runoff and leaching loss. Approach 3 with biochar application. Biochar is a form of biogenic charcoal produced from biomass such as rice husks and agricultural waste. When incorporated into the soil, biochar can sequester carbon for hundreds of years, enhance water retention, and reduce NO emissions by up to 45%. It also supports root development and improves fertilizer efficiency. However, pyrolysis technology still requires further development and dissemination among farmers. Approach for crop rotation with legumes. Crop rotation with leguminous plants such as peanuts naturally improves soil nitrogen content. This practice also disrupts pest cycles, reduces dependence on synthetic fertilizers, and enhances biodiversity. Unfortunately, many farmers overlook crop rotation due to a focus on short-term profits. Therefore, incentive programs are urgently needed to promote its adoption. When these four approaches are integrated, the results are synergistic. The use of mulch and drip irrigation helps maintain soil moisture, biochar strengthens soil structure, and crop rotation enhances natural fertility. Simulation models based on local data indicate that implementing all these strategies together can potentially reduce NO emissions by up to 50% per growing season. At the policy level, this approach aligns with Indonesia's national climate strategies, such as Proclam and the National Action Plan for GHG Reduction. Government support through Green People's Business Credit and farmer training is essential for large-scale adoption. In Sleman, the local agriculture office has also promoted precision farming in several villages. To scale up adoption, key policy interventions are needed, including subsidies for drip irrigation and small-scale pyrolysis equipment, farmer mentoring programs led by extension officers, and performance-based incentives through carbon farming rewards. The conclusion this video, the transformation of the Chile farming system toward low emissions can be achieved through an agroecological approach using organic mulch, drip irrigation, biochar, and crop rotation. This approach supports sustainable production, enhances soil resilience, and contributes to achieving national greenhouse gas emission reduction targets. However, its success depends on strong cross-sector collaboration and improved farmer capacity. So guys, this is my video. If you want to ask to learn more, we can discuss in the column below. See you in the next video.